Aloha class, here we go. Last section in chapter 8 where we kind of put it all together and we start solving these rational equations, okay? And we're going to use rational equations to solve these bad boys. All right, so here we go. If you notice, there's a lot of similarities with this problem with what we've been doing, but because of this magical equal sign, we actually don't have to do as much work as we did when we were adding or subtracting these guys. These are more like the complex fraction ones, okay? Now, what do I mean by that? Well, first and foremost, what we want to make sure we do is factor all the denominators. So if I were to rewrite this problem in factored form, it'd be x over x minus 3 plus x over x plus 3. And then hopefully we all know by now that x squared minus 9 is really x squared minus 3 squared. So remember, that's the difference of squares, which would be x minus 3x plus 3. Now, if you notice, if you look at those bottoms, there's a lot of similarities. So just like complex fractions, we're going to go ahead and find an LCD. And if you look very closely, I have 1, 2, and 3 fractions. So let's find the LCD for all of them. All right, we're going to start with x minus 3 because that's in the first one right here. Spling, that guy's gone. Then I compare it, remember. There's an x plus 3 here. Is there an x plus 3 already here? No, there is not. So I've got to add it. Spling, gone. Sweet. All right, now what do we got to do? Well, this guy, remember, factored to x minus 3, x plus 3. I already have an x minus 3 there. I already have an x plus 3 there. So I don't have to add anything, making that dude my lowest common denominator. Now, what do we do with it? Kind of like complex fractions. We don't have to multiply the top and the bottom by it because we've got that equal sign. We're going to multiply everything on the left with it, everything on the right by it. And since we have an equal sign, it's really like you're multiplying by 1. Because if I brought it back over, it'd be x minus 3 times x plus 3 all over x minus 3 times x plus 3. It'd cancel out. All right, so we're going to multiply everything. Now, if I multiply that by this guy right here, the x minus 3s will cancel out, and you'll be left with an x plus 3. If I multiply the LCD by this, the x plus 3s will cancel out. I carry that plus sign, and I'm going to be left with that x on top and an x minus 3. Now look at this sweet bad boy. If I multiply that by the LCD, spling, 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 everything goes away, and I'm just left with a 2. All right, so what do I got to do now? Well, I distribute x squared plus 3x plus x squared minus 3x equals 2. Now, there will be a lot of solving here, okay? So we combine like terms. 2x squared, spling, spling, equals 2. Now, if it was a true quadratic that had an x squared, an x, and a c term, ax squared plus bx plus c, we'd have to get a 0 on one side. But this dude here, there's just an x squared. So I just got to solve this bad boy. X squared equals 1, square root both sides. X equals plus or minus the square root of 1, and the square root of 1 is Ichiban. It's 1, so I am done. Now, the one thing you do have to be aware of for these problems is what we call extraneous solutions. And what's an extraneous solution? Well, it's when you get a solution, an answer, and it's no good. Now, these two answers, a positive one and a negative one, are good. Why? Well, the only thing that would have been no good in this case would have been a 3 or a negative 3, because it would have put a 0 in the bottom. And remember, we're never, ever allowed to have a 0 on the bottom. Remember when we did it earlier with restrictions? Same type of thing. If your solution is in the restriction, we got to cancel that dude out. And it's called extraneous. Get out of here, yo. All right. So that is problem number 1. Let's get on here to problem number 2. So if you notice, the cool thing about chapter 8 is whether we're adding, subtracting, whether we have complex fractions, or we actually have equations now, LCD and lowest common denominator is really, really important. All right, let's check out this bad boy. Woo! This guy looks involved. Remember, what's the first step? First step is to factor this stuff. So I've got my quadratic here. And if I factor that guy, I can do it the super duper fast way because of the 1. A 2 and a 3 is a 2 and a 1, spling, spling. X minus, x plus 2, x plus 1. Then we go to the next guy, right? That's an x plus 2. That dude's factored. I got the equal sign. All right, equal sign means we're going to do the technique of this LCD, but we're just going to multiply everything by the LCD. It doesn't have to be like that adding and subtracting that we did earlier, okay? So we take our first denominator and we write it all down here. Oh, sweet, check this out. Gone, gone, because it's written there. Then let's compare the next guy. X plus 2, already there. X plus 1, already there. That's my LCD. Let's multiply the left and the right by it, okay? If I multiply this whole thing by it, spling, 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 those guys both go away with both of those. So I'm just left with an x minus 1 on top. And whenever you have a quantity, you should always put it in parentheses when it gets rid of everything. Okay, guys? All right, plus sign carries down. Now, if I do this, that guy cancels. I'm left with an x plus 1. So you're going to be left with a 2x and an x plus 1 for that middle guy equals x plus 1's cancel out, and you're left with the x minus 1 and the x plus 2. So now we just got to do some multiplication. X minus 1 equals, x equals 1 plus, that'd be 2x squared plus 2x equals, here I got to distribute x squared plus 2x, do a little foil, right, minus 2. Let's collect all of our, actually, let's collect first before we get crazy. Gone, that guy becomes 3x positive, minus 1, gone, gone. This gets x squared plus 1x minus 2. Now listen, I've got that ax squared, I got the bx, and I got the c. So this means I got to get a 0 on one side. So we're going to get rid of that guy. We're going to get rid of this guy. And we're going to get rid of that guy. And why do I have to do that? Because we're solving these, and I got to get a 0 on that side. So I get x squared plus 2x plus 1. Now, do you guys at home have any idea of how I solve this guy? How I finish it off? Bing goes, right? We got to factor that bad boy, right? There's a 1 and a 1. I can do it the super duper fast way. Ichi, right? 1 times 1 is 1. Add them together, you get 2. So if I come over here, that's just going to be x plus 1 super duper fast equals 0. Remember, 2 parentheses like that means I got to solve both of them. X plus 1 equals 0. Minus 1 minus 1, it equals negative 1. And guess what? Since the second one is the same exact, do I really have to do it? No. I get one answer. They're the same answer. But the question is negative 1 allowed to be an answer? And guess what, class? It is not. Because if you put a negative 1 back in here, you're going to get a 0 in the bottom, and you can't do that. So this is what we call an extraneous, and you need to know what it means. An extraneous solution, okay, is x equals negative 1. All right, so that means there's actually no solutions for this problem. There is nothing that would make it true. There's nothing that would make the left side equal to the right side. Negative 1 actually would, but it's extraneous because it would give me a 0 on the bottom. And remembers, we cannot have a restriction as an answer. Boy, that was an interesting one. All right, let's take a look at another one. All right, those are nice and easy, Japanese. All right, let's look at a couple of these guys because a couple of these guys are a little bit different. You know, they look different, but they're actually pretty much a little bit more okay than the ones we've been doing. So we're going to do one of these guys. Let's pick the toughest one. Excuse me, which is number 19, equal sign. All right, what the heck do I do in this problem? Well, I've got four fractions. Well, if I've got 4 fractions, I need a lowest common denominator. Now, just like we did earlier, it is helpful if I rewrite this totally factored. And the only one you can rewrite factored, which would be 6, which is 2 times 3. So remember, we come over here, we choose our LCD. So to find our LCD, we write down everything in the first one. There's a 2 and an x. Spling, spling, gone. Then I compare the next one. 3. Is there a 3 over here? No, so I got to add it. There's an x there. Is there an x over there? Spling, spling. There is. Now, why did I have to change that 6? Because if not, I would have added a 6. But if you look, 6 is 2 and 3, and I already have a 2 and a 3. So the LCD would be multiplying all those guys together. So it's 6x. So all I got to do is this. Okay, I am going to multiply everything, the left and the right, by 6x. Now, I think when you get problems like this that are just ratios and they're not binomials where there's two terms in the bottom or sometimes three, the smartest thing is let's actually multiply all of these by 6x. And 6x is really 6x over 1. All right. And if I do that, I get 30x over 2x for the first guy, right? Which would be equal to 15. Kind of interesting, right? It gets rid of that fraction, which is really, really helpful. That minus sign continues. Then let's multiply 2 over 3 by 6x over 1, and I get 18x over 3, which reduces to 6x. And I think this is a little bit easier to deal with. Then I take my next guy, my 1 over x. And if I do that, multiply that by 6x over 1, I get 6x over x, which ends up being 6. And then my last one, 5 over 6, that would be plus, because I got to carry that plus sign down. And that would be 30x. Oh, whoops, I skipped a step. 30x over 6. And what is 30x over 6? Well, that's just 5x, Mr. T. And then look, there's not even an x squared. Since there's not an x squared, I'm just going to add this 6x over here. And if I do that, I get 15 equals 6 plus 11x minus 6 minus 6. I get 9 equals 11x. Divide by 11, and I get a final answer of 9 over 11 is equal to x. And guess what? Will that work? Let's check. The only thing that wouldn't work right here, or my only restriction, is x can't be 0, because 0 would make the bottom 0. So 9 over 11 is good to go. All right, how you feeling about that? Not that bad, right? Each one of the problems on this little list is of the similar variety, all right? So I think we're going to be okay with the rest of those. Let's keep on rolling so we can keep this video under 20, okay? All right, here we go. Let's look at something here, and it says check each solution. Let's do a tougher one here. Why don't we look at number 29? All right, I think picking the last one kind of holds suit for probably being one of the most difficult ones, okay? So I have 3 fractions here. Remember, 4 is a fraction. That's really 4 over ichiban, right? 4 over 1, when it's not written as a fraction, we actually always can. Those are all factored. So let's find the LCD. We take our first one, x minus 1, right? And then we check x plus 1. There's not an x plus 1 there, so we got to add it. Now that's 4 over 1. You could add a 1 there, but you never need to do that. So that's my LCD. So remember, what do we do with that LCD? We multiply it by all of these guys. If I multiply it by that one, the x minus 1s will cancel out, and I would be left with an x plus 1. Okay? And this one here, carry that plus sign down. That's so important. If I multiply this by the LCD, the x plus 1s cancel out, and you're left with a 3 and an x minus 1. Now, what's interesting with the 4, I guess you could say the 1s cancel out, right? But you're left with a 4 and everything else. So what do I got to do now? Let's just distribute and get crazy. 2x plus 2 equals, what equals? Why do I keep on doing that? 3x minus 3, distribute. And then here I should probably FOIL that first, or distribute. So I'm going to share that x with both of those guys, x plus that'd be x squared, I'm sorry, plus 1x, and then share that with both of those, negative x minus 1, spling, right? They go away, and then distribute that 4 in there. I'm going to collect some like terms here, 5x minus 1 equals, distribute that 4 in there. I get 4x squared minus 4. Okay, now I got an x squared. Whenever I have an x squared, I want everything over on the x squared side. Now, it is also very important, if you remember from earlier in the semester, we always want our x squared being positive. So that means I'm going to move this 5x over here, and I'm going to move this 1 over here. And if I do that, I get 0 equals 4x squared minus 5x minus 3. Now, I have to solve that. And we haven't done a lot recently that you're not allowed to do the super duper fast way. And I'm going to have to erase here, because to finish this bad boy, we're going to have to go back to first semester times, and we're going to have to see if we can do this. And I'm not allowed to do it the super duper fast way. So what do we do, class? Do we remember? See if you remember what number goes on the top. right? The number that goes on the top is 4 times negative 3, which is negative 12. The number that goes on the bottom is a negative 5. Then you have to ask yourself, does anything work? 2 times 6, not going to work. 3 times 4, not going to work. 1 times 12, oh my gosh, it's not going to work. Now, when nothing works, what do? QF it, right? Quadratic formula. And whenever we do the quadratic formula, we always do the discriminant first, right? A is 4, B is negative 5, and C is negative 3. So we do the little discriminant, b squared minus 4ac. I told you we're going to be using this bad boy the whole year. That would be negative 5 squared minus 4 times a, which is 4 times c, which is negative 3. That would be negative 5 squared, which would be 25. Negative 4 times 4 would be negative 16. Negative 16 times negative 3 would be a positive, what would that be? 48. And then if I add those guys together, I get a 73, which is positive. So now I just got a QF quadratic formula, which is x equal the opposite of b plus or minus b square root of the discriminant. And 73 you can't break down. All right, so I get to leave that like it, right? Over 2 times 8. So my final answer is x equals the opposite of b. Negative 5 would be a positive 5 plus or minus the square root of 73 all over 2 times 1, 2 times 4, 2 times 4, well, that would be 8. So I guess I got to go one more step over 8. Hachi, boom, donezo. All right. The good thing about this lesson, you guys, is it really touches on everything that we've learned all year, from factoring to quadratic formula and all that stuff, all right? So hopefully we were okay earlier, and if we were okay earlier, we should be able to be okay, all right, moving on here. Now, I think I got enough time to get through this word problem, okay? So let's go ahead and look at it. I don't know about you guys, but you all know I'm from the islands. So we would fly all the time to San Francisco, then San Francisco to Hawaii. Now, I guess the only good thing about the long flight is it always takes much longer getting to Hawaii than coming back. Because coming back, we get a tailwind. Going there, we get a headwind. Like, it's actually an hour difference. It usually takes about 9+ hours to get there, and sometimes only 7 hours and some change getting back. All right. So we're going to kind of look at this going from Chicago to San Francisco. If you notice, and I want you to take good notes here, okay? Going that way, it's 1850. That's how many miles it is. That's a lot of miles. Coming back, obviously the same exact. However, there's a big, big difference, right? When I am going west to east, so if I'm going from San Francisco to Chicago, right, my rate is faster. I'm going to go faster because I got that tailwind, okay? But when I go Chicago to San Francisco, I get a headwind. So that means my rate is not as fast. Okay, it's not. Now, if you notice, we're using a very famous formula that you've used forever, which is distance equals rate times time. So if you look at my last column here, my time column, they divide by r. So you have your distance over your rate, your distance over your rate. Now, what we're trying to do, and they kind of said it here, they said the round trip for this is 7 hours and 3/4 of an hour. All right. So if I was to look at this problem, and I'm going to erase here so you guys can see the rest of it. Okay. The total time spent is 7.75 hours, right? That'd be 7 3/4. And that's going to be equal to the time. Remember, we solved for time spent going from San Francisco to Chicago, which is faster, versus Chicago to San Francisco. And I did a poor job of this, but we always want to introduce our variable before we talk about it, right? And I said that with 780 plus, right, we get a little bit of a tailwind when we go home, okay? But we get a headwind when we come, so we have to make sure we subtract that. All right, and that's how we get our time, right? Total time 7.75 hours. That's a long trip, right? Imagine going to Hawaii. That's a total of like 17 hours. KKs? But if that's my total time, then I got my time to get to San Francisco and my time coming home from San Francisco, right? Okay. And then we just got to solve this bad boy. All right. So here we go. If you notice, this is why it's in this section. And then we'll solve it together. Remember, this is 7.75 over Ichiban. Over Ichiban. So remember, how do we do these? Well, we find an LCD. Remember, I got 1 as a guy, but we don't ever have to really put 1, but I have 480 plus x as a denominator, and I have 480 minus x. So I got to count both of those guys in my LCD. And remember, in these rational equations, we multiply both sides by your LCD. And if I do that by this, oh my gosh, you're going to get 7.75. You're going to get 480 plus x, 480 minus x, because nothing cancels out. But if I multiply this by it, the 480 plus x's cancel out, and you're left with this, right? Okay, I got to get done here pretty soon. I got a plus sign there. And if I do that, the 480 minus x's cancel out. So you're going to end up with a plus. Now, obviously, there's some big numbers going on here, but I should do this first, 7.75. And then here, I got my little calculator handy right here. I'm going to do 480 times 480. Oh my gosh, that's got to be huge. Holy moly. 230,400. And then I distribute it there, minus 480x. Now remember, these are conjugates. So what's cool about this is they cancel each other out. Spling, spling. And then minus x squared. And then if I keep on going here, I got to do 1850 times 480. And that gives me, oh snap, 888,000 minus 1850x. And then I get plus that same 888,000, but this time I get plus 1850x, which spling, those guys go away. But now I got to distribute. Holy moly, calculatora time. 230,400. That's going to be a huge number. 1785600. Ooh, just that. And then I got to multiply it all the way over there, and I get negative 7.75x squared. And that's equal to, oh my gosh, 888,000 plus the same thing gives you, holy moly, 1776000. And then I'm going to subtract this enormously huge number with this enormously huge number. Let's see what we get. We get negative 7.75x squared equals minus, let's see, 178,512, 3 zeros, and I get negative 9,000. How do I solve that? I divide by negative 7.75, negative 7.75, and I get x squared equals, let's divide it, 7.75 equals, let's find out what this crazy tailwind is. I get negative 1.1, what the heck? I get negative 1161.29. And then I just have to square root positive, because 2 negatives makes a positive. And then I square root both sides. And if I square root that number, I get, let's see, 1161.29. Take the square root of that bad boy. I get x equals 34.08. And that's how fast the headwind is. I am going to cut it right there because that's just at about 20 minutes, maybe a little bit over. I apologize. Bring your questions early tomorrow in class. That's chapter 8 at a wrap. Let's get ready for that big test coming up, right, class? Alohas.